Number 2, rank the following pressures in increasing order, which means we want to have our smallest pressures first and our largest pressures last. Now, in class, a lot of students were asking, like, do we need to convert all these? And in a sense, yes. However, these calculations are easy enough that you can actually do them in your head pretty darn easily. Now, the way my mind works, it's actually easier for me to compare everything to atmospheres. When I look at A right there, 50 kPa, I know that 101.325 kPa is the same as 1 atmosphere. All right, so 50 is about half of that. So I think of that number, I think of A as about half of an atmosphere. So right off the bat, I know that A is going to be smaller than B. All right, so I have that part done. Let's move on to C. Now, C is in torr. Now, I know that 760 torr is 1 atmosphere. I have 76. That's 1/10 of an atmosphere. Well, 1/10 is smaller than half of an atmosphere, which is what A was. So now I'm going to list C before A because C is even smaller than A. Now, D is a little bit tricky because we're pulling out a definition that we didn't really stress much in the lecture, and it is mentioned in the textbook, but who pays attention to the textbook? 1 Newton per meter squared is 1 Pascal. All right, so 100 newtons per meter squared is actually 100 pascals. It's 100 pascals. Now, like, what is a Pascal? Well, it's a very small unit of pressure. Because remember, when we make a Pascal unit that's equivalent to 1 atmosphere, we have to have 101,325 pascals in order to have 1 atmosphere of pressure. So having 100 of those is like being 1,000 times short of 1 atmosphere. You're like 1,000th of an atmosphere. It's very, very, very small. So it turns out D, 1,000th, is smaller than C, 1/10, which is smaller than A, which is 1/2, which is smaller than B, which is 2. And so, yes, you are carrying out conversions for each of these, but they are simple enough that if you are aware of the statements of equivalence, you can actually do them in your head.